we decided to look into determining the flaws within a 16th century hypothesis.
In the 16th century, Italian gamblers proposed that out of 3 dice, rolling a sum of 9 would equal rolling the sum of 10 because there are 6 combinations of getting 9 and 10. However, Galileo proposed that this was not true, and we are going to find out why.
So we decided to use theoretical data as well as actual data to test this situation.
To find the theoretical data, we propose that there are 216 possible outcomes because there are 6 faces on the die and there are 3 die. So 6 raised to the 3rd power is 216. Furthermore, we created a table that listed each possible outcome for each sum. This showed the sample space of the 3 dice. As seen in the sample space, the sum of 9 had a probability of 25 out of 216. On the other hand, the sum of 10 had a probability of 27 out of 216. Though it was a very small difference, they're clearly not equal. So to test the theory, we simulated the sums by rolling 3 dice.
So by doing our simulation, we gathered actual data. We rolled the 3 dice 395 times all at once and tallied how often each sum from 3 to 18, those being the possible sums, occurred. Rolling the dice 395 times allowed us to gather significant data and to later draw better conclusions. There was a lower frequency of the number of times a sum of 9 was rolled compared to 10. Again, the difference is not that large. However, it exists, thus also supporting Galileo's theory.
As stated before, there are 25 ways of rolling a 9, while there are 27 ways of rolling a 10. Also, for rolling a 9, there is a possibility of getting 3 threes rolled. However, there is only a 1 out of 216 chance to receive it. In addition, since 10 is greater than 9, there are naturally more possible combinations to receive this sum of 10.
So when we compared our theoretical data versus our simulation data, we found that they had many similarities. The graph of our data had a similar shape to the sample space, with the highest frequencies occurring at 10 and 11.
The similarities in the mean and standard deviations of the theoretical probability and the simulated probability show that our results were very similar, further proving Galileo's theory.
Overall, we were able to conclude that Galileo was correct in his hypothesis and his warning to the Italian gamblers that 9 would be less likely to be rolled as a sum than 10. By looking at our theoretical data, we can show that in the sample space this is the case, and by going through the simulation, we can also prove this as well. So Galileo was correct, and the Italian gamblers were able to come to a decision and later play their game accordingly.